We are team 5 and this assignment is going to evaluate the Boolean Algebra topic. In this case, the function to minimize is the one that is shown in the slide. So at the top of the slide we have the original function to minimize. In the first step we apply theorem number 4 part A. That is going to result in the second step, on which we are going to apply theorem number 1, which is the idempotency theorem. That is going to result in the third step, on which we apply the distributivity postulate. That is going to result in a sum of products function in the fourth step, on which we apply again the theorem number 4 part A to the first and last term. And on the final step, in order to obtain the minimum solution of this function, we apply the consensus theorem, which is theorem number 9 part A. And the final minimum solution of this function is not x c plus y not c.
How to verify that this reduced function is correct? First, we can construct the truth table so we can obtain the outputs of the minimize function. So now we can substitute all the inputs in the minimize function so we can verify that the outputs are the same. In the first one, we have that the inputs are 0. So we substitute and we have 0 multiplies 1 plus 1 that multiplies 0, and this is equal to 0. It's very important to know that in the input we have 0, but we know that x is 9, so that 0 changes to 1. In the second one, we have 0, 0, 1, and in the minimize function, now that it's substitute, we have 1 multiplies 1 plus 0 that multiplies 0, and this is equal to 1. So we can repeat this process to verify that all the outputs are correct. Then in the original function, we do the same process to verify that these outputs are equal to the outputs of the reduced function and verify that both are correct. In the first one, we have that all the inputs are 0, so we have that 0 multiplies 1, and that multiplies all the terms that are inside of the parentheses, so it's not necessary because we already know that we have a 0 multiplying that, and all will be a 0. Then we have a sum of products, and in one product we have that 1 it's multiplying 0 plus 1 that multiplies 0, so we have another 0 multiplying the other term, and we know that this is equal to 0, so finally the output will be 0. In the next slide, it can be clearly seen because we are applying the logic gates.
Continue with the demonstration. Here is the original expression and is represented here. Here is the expression we get and is represented here. Here we have the values of the truth table. This is our x, y, and z. The first combination is all zeros. We can see that the lights are off. If I turn on the Z, the light turn on both sides. Only Y also turn on both sides. Y and Z stays on. The next combination is only X and it will turn off. The next combination is X and Z. It stays off. Turn on the X and Y. and we should get a 1. And the last one is all on, and the light should turn off. Now we have seen that in both sides we get the same result.